Hello, students. Welcome to PAVE exam solutions for the paper of students going from 10th to 11th standard. So let's look at question number 1. So the question is asking us the sum of the first 5 multiples of 3. So the first 5 multiples of 3 are 3 itself, 6, 9, 12, and 15. And their sum is 45. So it's option A, 45. Look at question number 2. So we're asked the exponent of 3 in the prime factorization of 2025. So 2025 is equal to 3 power 4 into 5 squared. So the exponent of 3 in the prime factorization of 2025 is 4. So option D, 4. So let's look at question number 3. So we have two equations. So let's call this equation 1 and this equation 2. So we have equation 2 as 2025x plus 2024y equal to -1. This is equation 2, and 2024x plus 2025y equals 1. This is equation 1. So if we subtract equation 1 from 2, that is 2 minus 1, we get x minus y equals -2. And that's what we're asked. We're asked the value of x minus y, and that is option B, -2. So here, see this, so let's see question number 4. So we're asked the sum of 1, 2, 3 up to 50. So if you notice, this is an AP with first term equal to 1, common difference equal to 1, and how many terms are there? 50. So we can write Sn equals n by 2 into 2a plus n 1 into d. So this is equal to 50 by 2 into 2 into 1 plus 50 minus 1 into 1, which is equal to 25 into 2 plus 49, which is equal to 25 into 51. And we're asked if this sum Sn is sum 25k, then we're asked the value of k. So here we get the sum Sn is 25 into 51. So this 51 is the value of k. So it's option B, 51. Let's look at question 5. We're asked the value of x for which 2x, x plus 10 and 3x plus 2 are 3 consecutive terms of an AP. So if we have 3 consecutive terms A, B, C of an AP, we can write 2B equals A plus C. So here we can write 2 into x plus 10 equals 2x plus 3x plus 2. So we have 2x plus 20 equals 5x plus 2. And from here we have 3x equals 18 and x equals 6. So the answer is option A, 6. Let's look at question number 6. So we're given a quadratic is ax square plus bx plus c, which has coefficients that are real numbers a, b, c, and they form an arithmetic progression with this a greater than equal to b greater than equal to c greater than equal to 0. So what are we asked? We're told that the quadratic has exactly one root. Ax square plus bx plus c has one root, which means the determinant b square minus 4ac equals 0. And we also know that a, b, c are in AP. So from this, we can write 2b equal to a plus c. Now what are we asked? We're asked what is this one root of ax square plus bx plus c. So if a quadratic has exactly one root, the root is x equal to minus b by 2a. So from here we have b equals a plus c by 2. And if we put this value of b here in this equation, we get a plus c by 2 the whole square equals 4ac. So we get a square plus c square plus 2ac equals 16ac. So from here we get c square minus 14ac plus a square equal to 0. Now if we divide the whole equation by a square, we get c square by a square minus 14c by a plus 1 equal to 0. Now this is a quadratic in c by a. So from here we can write c by a equal to 14 plus or minus square root of 14 square minus 4 times 1 into 1 by 2, which is equal to 7 plus or minus square root of 192 by 2. So this is in turn equal to 7 plus or minus 4 square root of 3. Now we are told that a greater than b greater than equal to b greater than equal to c greater than equal to 0. So from that we have a greater than equal to c and c by a less than equal to 1, which means c by a can only equal to 7 minus 4 square root of 3. And because we know 2b equal to a plus c, we can write minus b by 2a equal to minus 1 by 4 minus 1 c by 4a. So this is the value of x. So x equal to minus 1 by 4 minus 1 by 4 into c by a. And we have the value of c by a. So now we can write minus 1 minus 7 plus 4 root 3 by 4, which is equal to minus 2 plus root 3. So the answer for question number 6 is C, minus 2 plus root 3. Now let's move to question number 7. So we're given a square ABCD whose area is 1. So the side is also 1. And the diagonal AC is extended beyond C. So this is AC. So this is AC and it's extended beyond C by 20 times its own length. So we have what? CE equal to 20 AC. Now the length, if CE equal to 20 AC, then AE equals 20 AC, that is CE plus AC, that is AE. So 20 AC plus AC, which is 21 AC. Now, imagine this big square whose diagonal is AE. Let the square be AXEY, right? So, the side of the square has a length 21. And let's draw a point, let's mark a point O on AB such that AO is equal to 1 by 21. That is AB by 21. So, and now let's connect AC. All right. Now, triangle BCO is a right angle triangle, or let's just say it's right angled, right? This triangle is right angled. Which one? This triangle. So we can find OC, right? Because if AO is 1 by 21, OB is 1 minus 1 by 21, which is 20 by 21. So OC square equals OB square plus BC square, which is equal to 20 by 21 the whole square plus 1 square, which equals 400 by 441 plus 1, which is equal to 841 by 441. So from here, we get that OC is equal to square root of 841 by 441, which is equal to 29 by 21. Now, let's see triangle BAE. That is this triangle, right? And triangle OAC. So in triangle, so what is triangle AOAC? So it's this triangle here. So in these two triangles, we have angle A is common, and we have AE equal to 21 AC. So we have this is 21 times this. And we also have AB equal to 21 AO, because that's how we've chosen AO, right? So AB is 21 times AO. So from this we get AE by AC equal to AB by AO equal to 21. So we have triangles BAE and triangle OAC as similar triangles. Now from here, because these two are similar, we have AE by AC equal to AB by AO equal to BE by OC equal to 21. And we already found OC. So because we know what OC is, BE equals 21 times OC. BE equals 21 times 29 by 21. So BE equals 21. So the answer to this question is, I'm sorry. So BE equals 29 because 21 into 29 by 21 is 29. So the answer to this question is D, 29. So let's look at the eighth question. So they're telling us that the area of an isosceles triangle is 12 centimeter square and the length of its equal sides is 5 centimeter. Now let's draw this triangle ABC where the area equals 12 centimeter square and AB equal to AC, all right, which is equal to 5 centimeter. So let BC equal to B, all right, let the base equal to some B and the height, let's say AO equal to some H. So the area of triangle ABC is half BH, right? And BO equal to OC equal to B by 2. And triangle AOC is right angled, right? So we have AO square plus OC square equals AC square. And we have H square plus B by 2 the whole square equals AC. We know AC is 5 centimeter. So 5 square. And from the area here, we know the area, right? What's the area? So 12 is equal to half BH and H is equal to 24 by B. And we can put this in this equation and we get 24 square by B square plus B square by 4 equals 5 square. If we multiply the equation by 4B square, we get, so here we have B power 4 plus 48 square equals 25 into 4, that is 100B square. So it's a quartic in B. But if you notice, it is a quadratic in B square, right? Because we don't have B cube or B terms. Now we can write this as B square the whole square minus 100B square plus 48 square equal to 0. And this 48 square can be written as 8 square into 6 square. So we have B square minus 64 into B square minus 36 equal to 0. So B square equal to 64 or 36. So B equal to plus or minus 8 or plus or minus 6. But side of a triangle cannot be negative, right? So the only values that are allowed for B are 8 or 6. So what are we asked? We're asked to find the sum of all possible values of the base. So that is 8 plus 6, which is 14. So the answer to this question, question number 8, is option B, 14. Right. Let's look at question number 9. Now, rectangle ABCD has AB 5 and BC 12. Now CD, that is this, one of the sides, is extended to a point E such that triangle ACE, that is this triangle, is isosceles with base AC. So base AC, the diagonal is the base, and AE equal to CE, right? Now, what are we asked? We're being asked what the area of ADE is. So this triangle. This is the area we're being asked. So this area is, so this is a right angle triangle, right? So area of ADE, triangle ADE, is half into AD into DE. Now, if we let DE equal to some X, and we know CD equal to some, we know CD equal to 5 and AD equal to 12, right? So if CE is X plus 5, so AE equal to CE equal to X plus 5. So AE is also X plus 5. But triangle ADE is right angled. Now, because AD is right angled, we can write 12 square plus X square equals X plus 5 the whole square, right? Now, we have 144 plus X square equals X square plus 10X plus 25. Now, these terms cancel out and we have 10X equals 144 minus 25, which is equal to 119. So we have X equal to 119 by 10, right? So what is the area of ADE from here? Area of triangle ADE is equal to AD. AD is 12 with half into AD, that is 12 into DE, that is X, 119 by 10. So which is equal to 357 by 5 centimeter squared. So the answer is 357 by 5. Okay, let's look at question number 10. We have, so we have this X plus 3a is a factor of this. Let this polynomial be P of X, right? So X plus 3a is a factor of P of X. That means P of minus 3a equals 0, right? So let's put minus 3a in this polynomial in place of X. So we have minus 3a the whole power 4 minus 9a square into minus 3a the whole square plus 5 times minus 3a plus 6a plus 60 equal to 0. So this simplifies to 81a power 4 minus 81a power 4. So these terms cancel out. Minus 15a plus 6a plus 60 equal to 0. So from here we have 60 equal to 9a, or a equal to 60 by 9, which is equal to 20 by 3. So the answer to this question is option A, 20 by 3. Let's look at question number 11. So we have to find positive integer x such that 1 by 10x equals, so now this 1 by x square plus x can be written as x into x plus 1 plus 1 by x square plus 3x plus 2 can be written as x plus 1 into x plus 2, and 1 by x square plus 5x plus 6 can be written as x plus 2 into x plus 3, and this can further be written as 1 by x minus 1 by x plus 1 plus 1 by x plus 1 minus 1 by x plus 2 plus 1 by x plus 2 minus 1 by x plus 3. So these terms cancel out, and what remains is 1 by 10x equals 1 by x minus 1 by x plus 3. So we have 1 by x plus 3 equals 1 by x minus 1 by 10x, which is equal to 9 by 10x. Now we have 10x equals 9 times x plus 3, which is equal to 9x plus 27. So from here we have x equals 27. So the answer is option B, 27. Okay, let's look at question number 12. So we have p of x. P of x is a quadratic polynomial with real coefficients, right? And we're given p of x equal to p of 2x square plus p of 1x plus p of 0. Now, can write let a equal to p of 2, b equal to p of 1, and c equal to p of 0. Then p of x can all can be rewritten as ax square plus bx plus c, right? And p of 0, if we put 0 in this equation, we get p of 0 as c, right? Which we already know. And p of 1 as a plus b plus c, which is also equal to b because we set it as b, right? So from here we get a plus c equal to 0 because these terms cancel out. And in turn, c equals minus a, right? Now let's write p of 2. So p of 2, if we substitute in this equation, we get 4a plus 2b plus c, right? Which is also equal to a because we set that, right? And from here we get 3a plus 2b plus c equal to 0. But we already got this. we got c equal to minus a. So now if we put this in this equation, we get 3a plus 2b minus a equal to 0, or 2a plus 2b equal to 0, or we get b equal to minus a, right? So we have c equal to minus a, right? And we have b equal to minus a. So b equal to c equal to minus a. Now what are we supposed to find? We're supposed to find p of, oh, and we're also given this p of 3. P of 3 is equal to 7. So if we put p of 3 equal to 7 in this equation, we get p of 3 equal to 9a plus 3b plus c equal to 7. And if we put b and c in terms of minus, if we put substitute this in this equation, we get 9a minus 3a minus a equal to 7. So a equal to 7 by 5. Now what do we have to find? We have to find p of minus 1. P of minus 1 is a minus b plus c, which is a plus c minus b, right? So if we put this result in this again, we get this is equal to a minus a minus of minus a, which is equal to a, which is 7 by 5. So the answer to this question is option A, 7 by 5. Okay, let's look at this question, question number 13. All right. So we're given a rectangle ABCD in which a point F is chosen on AD, right? This point. And point E is chosen on side CD. So this point. And segments B, BE, BF, and EF divide the rectangle into 4 triangles, right? 1 triangle, 2 triangle, 3 triangle, and 4 triangles. The area of these triangles are given by A, A plus 5, A plus 11, and A plus 18, right? Now we need to find the area of the rectangle ABCD. So let's start. So let's write, let's name AB as A and BC as B, right? This two sides of the rectangle. Let AB equal to A and BC equal to B, right? Now, what do we know? We know the area of, so in triangle ABF, so this triangle here, right? We know the area of the triangle. So area of the triangle is half into base into height, which is AF into AB, which is A, right? Now we know that area is alpha plus 5. So we can write AF as 2 times alpha plus 5 by A, right? We can write this as 2 times alpha plus 5 by a, right? And similarly, in triangle, this triangle here, right? In triangle BCE, can we write the area as half into base into height, half into CE into B, which is equal to alpha plus 11. So we can write CE as 2 times alpha plus 11 by B, right? So we can write this as 2 times alpha plus 11 by B. Now, what is this length? So AD equal to BC, right? Opposite sides of a rectangle are equal. So this is nothing but this minus this, right? So we can write DF equal to B minus 2 times alpha plus 5 by A, and similarly, what is this length? We can write, so this length is nothing but this minus this, right? A minus 2 times alpha plus 11 by B. So DE equals DE equals A minus 2 times alpha plus 11 by B, right? Now, in triangle DEF, we have area of the triangle equal to alpha, right? So, area of triangle equal to half into DE into DF, which is equal to alpha. So, the D and DF we know, we just found here. So, we can write this is equal to half into B minus 2 times alpha plus 5 by A into, just gonna write it a bit smaller. This is equal to half into B minus 2 times alpha plus 5 by A into A minus 2 times alpha plus 11 by B. Now, if we multiply this whole expression, we get half into AB and this into this is minus 2 times alpha plus 5 minus 2 times alpha plus 11 minus or plus 4 times alpha plus 5 into alpha plus 11 by AB, which is equal to, which is in turn equal to alpha, right? Now, we know that. So let's multiply the whole equation by 2AB. So we'll get AB the whole square minus. So let's add these two together. We get minus 2AB into 2 alpha plus 16 plus 4 times alpha plus 5 into alpha plus 11 is equal to 2ab into alpha, right? And we know that AB is nothing but the area of this rectangle, which means AB is equal to the sum of all areas of these triangles, which is alpha plus 5 plus alpha plus 11 plus alpha plus 18, which is equal to 4 alpha plus 34. Now let's go ahead and substitute that in the equation, and we'll get 4 alpha plus 34 the whole square minus 2 into 4 alpha plus 34 into 2 alpha plus 16 plus 4 times alpha plus 5 into alpha plus 11, which is equal to 2 times 4 alpha plus 34 into alpha, right? Now we can divide the whole thing by 4. So we'll get 2 alpha plus 17 the whole square minus 2 alpha plus 17 into 2 alpha plus 16 plus alpha plus 5 into alpha plus 11 equals 2 alpha square plus 17 alpha. Now let's expand this. So if we expand this, sorry, this is alpha. We have, so this minus this, right? We can write this as 2 alpha plus 17 into 2 alpha plus 17 minus 2 alpha plus 16, which is just 1, plus alpha square plus 16 alpha plus 55 equals 2 alpha square plus 17 alpha. So we can cancel these terms here. So we'll be left with alpha square plus 17 alpha minus 16 alpha minus 2 alpha minus 55 plus 17. That is 65. 72 equals 0. So we have alpha square minus alpha minus 72 equal to 0. So we can factor this as alpha minus plus 8 into alpha minus 9 equals 0. So the area of a triangle cannot be negative, right? So we have alpha equal to 9. But what do we need to find? We need to find the area of rectangle ABCD, which is this 4 alpha plus 34. So if we use that, area of ABCD equal to 4 times 9 plus 34, which is equal to 70. So the answer to this question is option C, 70. Question number 14. So we're given two equations and they're asking us the value of xy. So we have x square plus xy plus x equal to 12 and y square plus xy plus y equal to 18. Now let's go ahead and add these two equations. We'll get x square plus y square plus 2xy plus x plus y equal to 30. Now if you notice, this is just x plus y the whole square and this is x plus 5 or yeah into x plus y plus 6 equal to 0, which means x plus y equal to 5 or minus 6. So the answer to this question is option A, 5 or minus 6. Okay, let's look at this question here. So they're asking us what the remainder is if when these two numbers are divided by a same 3-digit number, the remainders are equal, right? So let's say they're both divided by the same 3-digit number x, and the remainder we get when they're divided by x is r, right? So we have 34,369 equals x times some quotient plus r. And similarly, we have 31,513 equals x times some quotient plus same r. So the reminders are same, right? Now if we subtract these two equations, so let this be 1 and this be 2. So 2 minus 1, we have 2856 equals x into q1 minus q2. So x is a factor of 2856 and x is a 3-digit number, right? So let's list all the 3-digit factors of 2856. So the 3-digit factors of 2856 are, so 2856 can be written as 3 times 952, 4 times 714, 6 times 476, 7 times 408, 8 times 357, 12 times 238, 14 times 204, 17 times 168, 21 times 136, 24 times 119, and 28 times 102, right? Now, if we divide these two numbers by 952, we get 97 as the remainder. in both cases. So the remainders are equal and the answer is option B, 97. Let's move on to the next question. Question number 16. So if the roots of this equation are equal, so the determinant is 0. So we have c minus a the whole square equals 4 times b minus c into a minus b. And if we expand this, we get c square plus a square minus 2ac equals 4 times ab plus bc minus b square minus ac. And we can move the ac term this side. So we have c square plus a square minus 2ac plus 4ac, which we can write as just plus 2ac is equal to 4 times a plus c minus b. And this is a plus c the whole square, which is equal to 4 into, or sorry, here we had, this is 4b times this. So this is 4b into a plus c minus 4b square. Now if we send all the terms this side, we have a plus c the whole square minus 4b into a plus c plus 4b square equals 0. Now let's divide the whole equation by b square. So we get a plus c by b the whole square minus 4 times a plus c by b plus 4 equals 0. And this factors out to be, so this is a quadratic in a plus c by b. So from here we get a plus c by b minus 2 the whole square equals 0. So a plus c by b equals 2. So we've been asked the value of a plus c by b, which is option A, 2. I hope all of you have used a protractor before. So let's mark the points here in this diagram first. So let's take the center of this semicircle as O and this line as XY and these points as A, B, and C, right? Now let's draw the radii OA, OB, and OC, right? Now we know that this angle YOC is 10 degrees and this angle YOB is 50 degrees and this angle YOA is 140 degrees, right? Let's write that down. We have YOC equals 10 degrees, YOB equals 50 degrees and YOA equals 140 degrees. So in triangle AOC, that is this triangle here, right? We have COA, angle COA equals 140 degrees minus 10 degrees. This one, which is equal to 130 degrees. So we have, let's say, this angle is sum y, which is equal here because this is an AOC is isosceles. And in this triangle, this angle is same as this angle. Let's say some z, right? So we have y equals 180 minus or 2y equals 180 minus COA, which is 50 degrees, right? So y is 25 degrees. And similarly, for z in this triangle, AOB, right? We have angle BOA equals 140 degrees minus 50 degrees, which is 90. And similarly, we have 2z equals 180 degrees minus BOA, which is equal to 90 degrees. So z is equal to 45 degrees. So what do we need to find? We need to find x, this angle here, which is nothing but z minus y, which is 45 minus 25, which is equal to 20. So the answer to this question is option C, 20 degrees. Now let's see this question, question number 18. We have x equals 1 by root 3 minus 1. So let's rationalize the denominator and we have x equals root 3 plus 1 by 2. Now let's isolate the third. So from here we have 2x minus 1 equals root 3. And if we square this on both sides, we get 2x minus 1 the whole square equals 3. And from here we have 4x square minus 4x plus 1 minus 3 equals 0, or just 4x square minus 4x minus 2 equals 0. Now, if we divide this polynomial by this, right, we have 4x cube plus 2x square minus 8x, I'm sorry, yeah, minus 3 by this. So we have 4x cube minus 4x square. So this is equal to minus 2x plus 6x square minus 6x minus 3, right? So now this can be written as 4x square minus 4x minus 2 into x plus 3. But we know if x equal to this, 4x square minus 4x plus 2 equal to 0. So because this is 0, this whole thing is 0 and the polynomial is 0. So value of this is 0. So the answer to this question, question number 18, option A, 0. Let's see question number 19. We are asked the sum of all 3-digit natural numbers which are divisible by 11 but not divisible by 22. So 3-digit multiples of 22, I'm sorry, three digit multiples of 11 but not 22, or just 3-digit odd multiples of 11. Odd multiples of 11. So what's the smallest 3-digit odd multiple of 11? So we have 110, but 110 is not odd. And then we have 121, right? And then we have 143 up to, we have 990, but 990 again is not odd. So the one before that is 980. I'm sorry, 979. So this is an AP with first term equal to 121, common difference 22, and now this is the last term, which is a plus n minus 1 times d, right? So if we put all these values and try to find n, we have 121 plus n minus 1 into 22 equals 979. So from here we have n minus 1 equals 979 minus 121 by 22, which is 858 by 22, which equals 39. So n is equal to 40. And we have the sum of an AP Sn equals n by 2 into a plus l, which is equal to 40 by 2 into 121 plus 979, which equals 20 times 1100, which is 22,000. So the answer to this question is option A, 22,000. So let's look at this question. Question number 20. So here we have these two sides equal. So we have this triangle as an isosceles triangle, which means this angle is also 37. And this is the external angle of the triangle. So we have angle CBD equal to 37 plus 37, which is equal to 74. And we have this angle equal to this angle because these sides are equal and this is an isosceles triangle. So we have angle X plus 74. So this is 74 and this is 74. 74 plus 74 equals 180, which means angle X is 32 degrees. So the answer to this question is option C, 32 degrees. So let's look at this question. Question number 21. So we have to find the value of 0.7 bar plus 2.7 bar. So if we take 0.7 bar as x, we have 10x equals 7.7 bar. And from if we subtract equation 1 from 2, that is 2 minus 1, we have 9x equal to 7, which means x equal to 7 by 9. And 2.7, 2.7 bar is just x plus 2, which is 27 by 9 or 25 by 9. So if we add 7 by 9 plus 25 by 9, we get 32 by 9, which is 3, 5 by 9, which is 3.5555 to infinity, which is 3.5 bar. So the answer to this question is option D, 3.5 bar. So let's look at question number 22. Alpha and beta are the roots of the equation x square plus x minus 4. 7 times 4, 7 times 2. So if you look at this right away, you notice that this is divisible by the number that has 7 ones. So if we go ahead and divide it, we get 4000002, right? And this can be written as 6 times 6666667. So this whole number, this one can be written as 6666666 into 6666667. So we have x square plus x minus 6666666 into 6666667 equal to 0. So we have x plus into x minus equal to 0. So x equal to minus and so the sum of unit digits of the two roots, that is 6 plus 7 equals 13. So the answer to this question is option D, 13. So let's look at question number 23. So we're told that from a rectangle of dimensions 11 by 13, 4 congruent triangular corners are cut off. So corners are cut off so that we get a regular octagon. Octagon has 8 sides of equal length, right? So if the triangles are congruent, then the sides must be the same. So if these two sides are xy, then it should either be xy here or yx. Now, if we think about it, if it's like this, if we have, so the two possible cases are this, right? Such that these two sides are equal. So 13 minus 2y equal to 11 minus 2x, or could be something like this. So if this is xy, this is 13 and this is xy, like this. So here what will we get? Here we'll get 13 minus x plus y equals 11 minus x plus y, which is never possible, right? So we won't be considering this case. So let's talk about this case. So we have 13 minus 2y equals 11 minus 2x, and this is the hypotenuse of these triangles, which is square root of x square plus y square. And that is also a side of the regular octagon. So we have x square plus y square also equal to this. So from here, we get 2y equals 2 plus 2x, right? Let's write this down properly. We have 13 minus 11 equals 2y minus 2x. So we have 2 plus 2x equals 2y. So here y equals x plus 1. So if we put this in any one of the equations, we have square root of x square plus x plus 1 the whole square equals 11 minus 2x. Now if we square on both sides, we get 2x square plus 2x plus 1 equals 121 minus 44x plus 4x square, right? Now if we bring all the terms to one side, we have 2x square minus 46x plus 120 equals 0, or x square minus 23x plus 60 equals 0. Now from here we can find x. So what is the value of x? X equals 23 plus or minus square root of 23 square is 529 minus 4 times 60, that's 240 divided by 2. So x equals 23 plus or minus 17 by 2, right? So we get x equals either 23 plus 17, that's 40 by 2, 20, or 3, right? So if x equals 3, then the length of the side is 11 minus 2x, which is 5, or 11 minus 2 times 20, that is minus 29. So the side of an octagon cannot be negative, so this is wrong. So the answer to the question 23 is option D, 5 centimeters. So let's look at this question here. Question number 24. In an equilateral triangle, we're given BD. So ABC is equilateral, right? So this is equal to this is equal to this, right? Similarly, this triangle here, has two equal sides, and this is equal to this. So all these are equal, right? Now we have one common angle here in this triangle and this triangle, and these two sides are equal, and 1/3 of this, right? So the ratio of this by this is equal to the ratio of this by this, right? So we have, so first of all, we have BD equals DE equals EC, right? And BD is 1/3 of BC, and because BD equals DF and BC equals AC, DF is also equal to 1/3 AC, right? And this angle is common in the two triangles. So in triangle BDF and triangle BCA, angle B is common, and BD by BC equals DF by AC equals 1/3, right? So triangle BDF is similar to triangle BCA. So if triangle ABC is equilateral, then the smaller triangles are also equilateral, right? With side length exactly 1/3 of the bigger triangle ABC. So if this side is A, then this is A by 3. Similarly, if this height is H, this height is, this height here is H by 3, right? So the areas of small triangles equal to half into A by 3 into H by 3, right? Area of triangle ABC equals half into A into H, right? So they're asking us the ratio of the shaded region to the triangle of to the area of triangle ABC. So area of the shaded region by area of ABC, which is equal to area of the shaded region is area of triangle ABC, that is half AH minus, this is nothing but 1 by 18 AH, right? The smaller area. So we're subtracting the area of the two smaller triangles, which is 1 by 18 AH minus 1 by 18 AH by half AH, which turns out to be 7 by 9. So the answer to this question is option B, 7 by 9. So let's see question number 25. So here we're given that A, B, and C are the roots of the polynomial x cube minus 120x plus 84 equal to 0, right? So if you notice here, we don't have an x square term, right? Which means that the sum of the roots, that's A plus B plus C, is 0, right? And because a plus b plus c is 0, we can also write c as minus of a plus b, right? And what are we asked? We're asked a power 7 plus b power 7 plus c power 7 by a power 4 plus b power 4 plus c power 4. So a power 4 plus b power 4 plus c power 4 is equal to a power 4 plus b power 4 plus minus of a plus b whole power 4, right? Which is nothing but a plus b whole power 4. So let's expand this. So we have a power 4 plus b power 4 plus a power 4 plus b power 4 plus 4a cube b plus 4ab cube plus 6a square b square, which is equal to 2 times a power 4 plus 2a cube b plus 3a square b square plus 2ab cube plus b power 4, right? And now, so let's try to separate some terms. So now here we can write this as a power 4, or rather a square the whole square plus b square the whole square, and this 3a square b square can be split into two terms. So first a square b square, that we'll write as ab the whole square, and then 2 times a square b square plus 2 ab into b square plus 2 ab into a square, right? So this comes out to be 2 times a square plus ab plus b square the whole square, right? Now let's take a power 7 plus b power 7 plus c power 7. So this can also be written in a similar way as a power 7 plus b power 7 plus minus of a plus b the whole power 7. So once we write it like this, can we expand this? So let's expand this and we get a power 7 plus b power 7 minus a power 7 plus 7a power 6b plus 21 a power 5 b square plus 35 a power 4 b cube plus 35 a cube b power 4 plus 21 a square b power 5 plus 7a b power 6 plus b power 7. Now these terms cancel out, right? And we can take the 7ab outside, right? All the terms have a 7ab. So we can take 7ab common and write a power 5 plus b power 5 plus 3 times ab into a cube plus b cube plus 5 a square b square into a plus b, right? Now if you notice, we can also take a plus b common, right? So we have this equal to 7ab Oh, I'm sorry. This was supposed to be negative because we have a negative sign here, right? We're subtracting here. So here we have negative 7ab, right? Here. And this, the leading term here will also be a negative 7ab. So you have equal to negative 7ab into a plus b into a power 4 minus a cube b plus a square b square minus ab cube plus b power 4, right? Plus 3ab into a square minus ab plus b square plus 5a square b square. So we have 7ab to a plus b. And can we write this as minus of a plus b, right? And that would just become c because a plus b plus c is 0. So we have minus, or so we're sending this minus inside, right? Here. So because we have minus 7ab and a plus b, so we can rewrite this as minus a plus b, right? Into 7ab into this whole expression. And this minus of a plus b, as we saw before, because a plus b plus c is 0, is just c. So we can write this as 7abc into, so if we simplify this over here, we have a power 4 and we have plus 2 a cube b plus 3 a square b square plus 2ab cube plus b power 4. And we've already seen this somewhere, right? This is nothing but this. So we have this is equal to 7abc into a square plus ab plus b square, the whole square, right? Now what have they asked us? They have asked us a power a power 7 plus b power 7 plus c power 7 by a power 4 plus b power 4 plus c power 4, which is equal to 7abc into a square plus ab plus b square, the whole square, divided by 2 times a square plus ab plus b square, the whole square. So these two terms get cancelled and we have this equal to 7abc by 2. And if we look at this polynomial, we have the product of roots as minus 84. That is ABC equal to minus 84. Now if you put this here, we have 7 times minus 84 by 2, which is equal to minus 294. So the answer to this question is option D, minus 294, right? So let's see question number 26. So in a class, the students are made to stand in rows, right? So let's say there are X rows and Y students in each row. So total number of students equals xy, right? So if one student is extra in a row, that is y plus 1, right? There would be two rows less. So y plus 1 into x minus 2 equals xy, right? But the total number won't change, right? And similarly, if one student is less in a row, there would be three rows more. So if one student is less in a row, there would be three students, there would be three rows more. So x plus 3 equals xy, right? Now, if we expand both these, we'll get from the first equation, we'll get xy minus 2y plus x minus 2 equals xy. And the xy term get cancelled, right? And in the second equation, we have xy minus x plus 3y minus 3 equals xy. And these xy term get cancelled. And we have from this equation that x equals 3y minus 3. And if we put that in the first equation, we have minus 2y plus 3y minus 3 minus 2 equal to 0. And when we simplify this, we get y equal to minus 5. And if we put y equal to plus 5. And if we put this in the equation x equal to 3y minus 3, we get x equal to 12. And they're asking us the to find the number of students in the class, that is xy. So once we found xy, x and y, xy equals 60. So the answer to this question is option B, 60. So let's look at question number 27. So we have 2 power x equals 8 power y minus 1, which can be written as 2 power 3 power y minus 1. Here we'll multiply the powers, right? So we have 2 power 3 times y minus 1. So this simplifies to x equal to 3y minus 3, right? And we have 9 power y, which is equal to 3 power 2y equal to 3 power x minus 6, right? So from this we get 2y equal to x minus 6. And from the first equation we have x equal to 3y minus 3, and if we substitute that in this equation, we get 2y equal to 3y minus 9. So from here we have y equal to 9, right? And if we put this value of y back in any of the equations, we have x equal to 3 times 9 minus 3, which is 24. So x plus y equal to 9 plus 24, that is 33. So the answer to this question is option C, 33. So the expression 14 power m minus 6 power m will always be divisible by. So let keep this in mind. A and B are integers. A power m minus B power m is always divisible by A minus B. So 14 power m minus 6 power m is always divisible by 14 minus 6, that is 8. So the answer to this question is option A, 8. So let's see question number 29. So we have A1, A2, A3 up to AN in an AP and A1 equal to 0, right? So the first term of the AP equals 0. And if we write the AP as first term, so A1, A2, A3 up to AN, if the first term is 0 and the common difference sum D, we can write this as 0, D, 2D up to n minus 1 times D, right? So once we write this, so can we write? So we're asked to find the value of A3 by A2 plus A4 by A3 plus up to AN by AN minus 1 minus A2 into 1 by A2 plus 1 by A3 up to 1 by AN minus 2, right? Now let's group the terms which have the same denominator, right? So we have A2, A3 up to AN minus 1 here and A2, A3 up to AN minus 2 here. So let's write A3 minus A2 by A2 plus A4 minus A2 by A3 plus up to so we're starting from 3, 4 up to we'll have AN minus 1 minus A2 by AN minus 2. And we'll have this extra term here with the denominator AN minus 1 because it doesn't exist in this series here. So plus AN by AN minus 1. So we can't group that term, right? So A3 minus A2 by A2 is 2D minus D by D. A4 minus A2 by A3 is 3D minus D by 2D up to N minus 2D minus D by N minus 3 times D. So all these terms plus, so AN minus 1, AN is N minus 1 into D divided by N minus 2 into D. So all these terms turn out to be 1. So 2D minus D by D is 1, 3D minus D by 2D is 1, up to N minus 2D minus D by N minus 3D is also 1. So we just need to see how many terms these are. These are N minus, so we have D 2D up to N minus 3D. So this is N minus 3 times 1 plus we have N minus 1 by N minus 2. Now this term N minus 1 by N minus 2 can be written as, so we have N minus 3 plus N minus 2 plus 1 by N minus 2. So we can write this as n minus 3 plus n minus 2 by n minus 2 plus 1 by n minus 2, which is, so this becomes 1, and we have n minus 2 plus 1 by n minus 2. So the answer to this question is option D, n minus 2 plus 1 by n minus 2. Let's see the last question of this paper. So here we're given some squares and we're given the areas of the squares inside them, right? They're asking us to find the area of this tilted square, right? Now, let's see. Now, these angles are the same, right? And these angles are the same. And these angles are the same, right? So, these three triangles are similar to each other, right? And let's say we draw a triangle like this. This is also similar to all these triangles, right? Now, can we find this height? So let's first find the sides of these squares, right? Side of this square here is square root of 3. Side of this square here with area 12 is square root of 12, which is 2 root 3. And the side of this square here is square root of 27, which is 3 root 3, right? And this distance here is the side of this square minus the side of this square, right? So we have this distance here as 3 root 3 minus 2 root 3, which is root 3. So if we draw this diagram again, we have so this is this triangle, right? And we have one small triangle inside that. That is this triangle, right? So this height here is root 3 plus 2 root 3 plus 3 root 3, which is 6 root 3, right? And yeah, and do we know this, the base of the small triangle, which is root 3, and the height of the small triangle, which is just the side of this square here, which is 2 root 3. And because these two triangles are similar, can we find, so if we know two sides of these triangles, can we find the third side? Because it's a right angle triangle, right? So the hypotenuse of this right angle triangle will be h square equal to, or let's just say h square equal to 2 root 3 the whole square plus square root of 3 the whole square, which is 4 into 3 plus 1 into 3, which equals 15. So this length here is square. So this h is square root of 15. So this length here is square root of 15, right? Now let's name these triangles first. Let's say this is ABC and this is XYZ, right? So the angles, so the triangle ABC is similar to triangle XYZ, right? And XY by AB is equal to XZ by AC, right? And AC is the side of the square. So once we find the side of the square, we can find the area of the square, right? So X, what is XY? XY is 2 root 3. Or first let's rearrange this. So AC is equal to XZ into AB by XY. So now if we put the values here, we have XZ equal to square root of 15, AB equal to 2 root 3, and XY equal to, I'm sorry, AB is 6 root 3, right? And XY is 2 root 3. So 2 root 3 gets cancelled out and we have AC equals 3 square root of 15. So area of tilted square is AC square, which is equal to 9 square into 15, which is equal to 225. Oh, I'm sorry. This is supposed to be just 9 here, right? It's just 3 square into 15. So, sorry, what did I do? 3 square into 15 is 135. So, the answer to this question is option C, 135. All right. Thank you, everyone. That's the end of PAVE question paper. For students going from 10th to 11th grade. All right. Thank you so much. Have a good day.